Ron, you wonder why I come to this stuff. Tim, you're my kind of sergeant at arms, brother. I really like that. So anyway, keep filling in. Our our guest today is a good friend of mine, Ron Elliot. Ron, before his retirement from Oklahoma State, he was the department head of Biosystems and Engineering at Oklahoma State. He also is the co-founder of the Oklahoma Mesonet. And Ron has his BS and MS from University of Illinois and his master's from Colorado State. And he and his wife, Judith, they've been residents of Stillwater for 40 years. So it's a great honor to have my good friend, Ron Elliot. Come on up.
Thank you, Chris. I appreciate the invitation. I'm going to have to be on fairly good behavior because I know a bunch of you. And I guess I was warned this is being recorded too, so I'm going to have to be real careful because it'll be there for posterity. But it's great to be with you today. And don't blame me for the weather, and don't give me credit when the weather is good. We just report what's going on out there. So I'm going to talk fairly briefly about what the Mesonet is and does, and then I'll get more into some of the data that we've uncovered over the last 27 years. And I'll finish up with a little look at the February cold snap. Do you still remember last month? Are we young enough that we don't forget those kinds of things? So I've got a little bit of information about that as well. I always like to start these talks with how many of you have heard of the Oklahoma Mesonet before today? Most, a high percentage. How many of you have the app on your smartphone for the Mesonet where you can pull up the data? Okay, we'll work on that. I think all of you that use a smartphone would benefit from that free app, and I'll mention it later. So, and then if you watch the weather on TV, you actually are getting a large dose of Mesonet. It's just that those meteorologists don't always give us credit, which is okay, but a lot of the data that they're presenting as far as weather around the state comes from the Mesonet. So I'll get started, and I guess we'll have some time for questions after the presentation, as I understand it. Okay, it's not advancing. I'm doing the right arrow, but should I just hit the space bar or something?
See if that. Now let me get out of here a second. Well, we're doing a lot of things at once here.
It's there. It must have just locked up. So
It's working
There we
now.
go.
So, but I need to share it again, so bear with me. All right, share that screen.
that's okay.
Okay, see if it's going to work.
So millions of people around the world are now seeing this, right? Is that
16 anyway.
okay?
Still not working? All right, we're fine. We'll go and test it. Let me try it again. Turn this thing off because it's creating some feedback.
Chris, this time doesn't count.
Whoa.
We'll be here for about 4 after that.
Professors are used to going for 50 minutes. That's what you told me. Okay.
Bit over there. Tell you what, give me your flash drive and I'll just run it separately over there.
Okay.
Okay, you're good to go.
So am I good to go? Okay. Well, it's a weather and soil monitoring network. It's actually widely recognized beyond our borders, both nationally and internationally. It's gotten a great deal of attention as a premier network. And it's believe it or not, a joint project of the Sooners and the Cowboys. OSU and OU have worked hand in glove on this from the beginning, and it's turned out to be great. We have 120 remote stations right now. On average, they're spaced about 18 miles apart. You see the dots there. The reason for the concentration in Payne County is that we have several ag experiment station locations there, and there's kind of a commitment to have a Mesonet site at each one of those. So it's not that Payne County is special in other regards, but we cover the state well. This is a typical station, about a square plot of land, about 30 feet on a side, a tower that's about 30 feet in the air. That wind sensor at the very top, I think, is 10 meters or 33 feet. And the one characteristic of these weather stations is they're remote. They're out in pasture and rangeland. They're not the type weather station you'll see next to an airport runway or on the lawn of the county courthouse. We want to get out and measure the real environment out there. So they're very much remote locations. I won't go into a lot of the technical detail. I mean, we could talk for a long time about individual sensors and how everything hooks together, but we have a total of 3,300 sensors. They report in every 5 minutes, which is another unique feature of our network compared to many others. It's very much a real-time network. Last I knew it, the number's probably up by now, but we're observing about 700,000 pieces of data a day. We have two-way communications from the site to bring the data in, but also we can talk back to the sites. These are solar powered. As I mentioned, we're in remote locations, have a battery system. We have a lot of redundancy. There's 30-day backup on site. So if we miss something because of communication problems, we haven't lost the data forever. It's still sitting there in a data logger. And we have well over 60,000 products and files that we produce every day for the users of Mesonet data. So it's a pretty comprehensive network in many ways. The things that we sense out there are the ones you'd expect: air temperature and rainfall, and down at the bottom, wind direction and wind speed. Those are probably the first things that come to mind. But we have relative humidity at every location, soil moisture, soil temperature, solar radiation, and station pressure. And again, not all networks have all of those variables measured. A lot of diverse uses, as you might expect. In Oklahoma, we're a very weather conscious state for good reason. And that's just a laundry list. It's probably not complete, but the data are used in so many different ways, more than we even envisioned when we first established the network. So I want to talk just briefly about how you access it. I know a lot of you already do, but some don't. And I think you'd find it very informative. This is our website. So if you don't remember anything else from today, if you just go to mesonet.org, you'll get to a home page. This one is set for Stillwater. You can pick any station in the state to be kind of your home one, but there's literally hundreds of different links and maps and tables and charts in there. You can surf to your heart's content. You see at the top, across the top are some of our main categories, like, forecast information, education, agriculture, public safety, and so on. And then I mentioned the smartphone apps. Whether you have an iPhone or an Android, there's a free, it's very simple to download, very simple to use. It's not a complicated thing, but I refer to mine many times a day, and I know some of you do as well. And so if you're on an iPhone, the App Store, on an Android, the Google Play, and you can just, if you search for Oklahoma Mesonet, you'll find this app. So I'd highly recommend it. Take a few minutes to download it. The Mesonet's very much a team effort. Everybody kind of pulling in the same direction. First of all, we have to have the willing landowners out there that let us set up camp sort of semi-permanently on their property. We have a tremendous staff based in Norman. That's kind of our headquarters. They're very good at what they do, and they're passionate about it. We have a steering committee. That's a small group that I co-chair. We have 6 steering committee members, 3 from Stillwater and 3 from Norman. And then we have a lot of partners, agencies, organizations, federal, state, private, a lot of partnerships going on. And the legislature has backed us well from the beginning. Our money flows through the state regents and to OU and OSU, where we've also had really strong support. They kind of let us do they let us do what we do. There's not a lot of administrative interference or anything like that. They're 100% supportive. And the bottom line for all of us that work on this is it's for the good of Oklahoma and its citizens. That's what we're really all about. It's a service. Some people have called it a state utility in a way, but we're happy if we're serving people well. So I wanted to jump into some actual numbers measured. We've been at it 27 plus years now. The planning started in the late 80s, but we became fully operational in 1994 to the present. So I think we've kind of proven ourselves after 27 years that it's here to stay. So we'll do a little audience participation. What do you think is the highest temperature we've ever recorded? You can shout it out. You can keep it to yourself. I'm not going to dwell on these like a school teacher for very long, but just think about what do you think the highest temperature we measured in all that 27 years? Well, we got to 115, 6 different times, and interestingly enough, in 6 different locations, and they aren't all in West and Southwest Oklahoma either. So it can get hot here, right? That's for sure. The lowest temperature, kind of pick your winner there. And what did I hear? 31. You have hit it. Winner. It wasn't that long ago, 4 years ago, Nowata up northeast of us hit 31 below. That'll get your attention. Okay, you got to think about this one. The hottest daily low temperature. So you take the low temperatures for a day. Which one was the hottest or the highest out of all the low temperatures? 89 is the winner. And guess where it was? Stillwater, America, back in 2012. So I hope your air conditioner was running okay that night, all night long. The coldest daily high temperature. So the kind of the flip side of all the high temperatures measured, which one was the lowest or coldest? Winter. 1. Medford up north of us had a high of 1 about a month ago. February 15th is probably etched in your memory a little bit. Okay, shifting gears now. Number of days with a high temperature of above 100. This would be at a single site in a single year. So how many days did a particular site have above 100 degrees in a year? 101. Would not have been a good summer to be in Granfield. 101 days above 100 degrees, if you can imagine that. And this is a map actually of statewide. You see the 101 down there in the lower left in the southwest. Stillwater, Payne County was around 60. So that summer of 11, we had 60 days above 100 degrees. If you're out at Kenton, Oklahoma, the far west panhandle, just 15. Elevation helps sometimes. Okay, greatest 1 hour temperature change. And I'll add something to this. Which direction do you suppose in 1 hour, does it change more up or down? Everybody's got that figured out, right? So yeah, down is correct. And the number I believe is 40. May Ranch up near the Kansas border. You go from shirt sleeves and an hour later, you're freezing. 40 degrees in 1 hour. Greatest 7-day temperature change. Same idea, but for over 7 days. 110, and it goes with our friend up there at Nowata. They went from that minus 31. A week later, they were at 79. So the poor plants, they don't have a chance. They don't know what to do. And this is a statewide map of that same thing. You see the 110 up there in the north east, but Stillwater had a 101 degree change during that same time period in February of 11. So we noticed it too, for sure. Highest wind gust recorded by the Mesonet in the last 27 years. It's the big one, 151. Our El Reno site was pretty close to that tornado that ripped through there in May of 11. And it got up to 151, and that wasn't right in the tornado, but it was pretty darn close to it. Highest 1 hour rainfall recorded, again, at any site. They're all big numbers, aren't they? But the winter was a 6.47 out at, I wouldn't have guessed it was in far western Oklahoma, but Cheyenne had about 6.5 inches of rain on that day, or that hour rather. The highest 1 day rainfall. Again, these are awfully big numbers. 14.2 at Fitztown, just about 3 years ago is all. That would have been what they call a gully washer, I think. Now we're going out to a full year. So one of our sites had the most rainfall total in one calendar year, and that would be Stigler over in the east, 88 plus inches in 2015. That, I figured that's almost averaging 1/4 inch of rain a day for a whole year. If you think about what to get to 88, of course, that's not the way it came, but they were wet. Okay, longest number of days with no precip measured at a single site. 0 precip measured. How many days in a row? Out there in the Panhandle, Hooker went 136 days with no rain, period. Okay, now I'm going to turn quickly to the, I call it the Arctic blast of last month, fresh on our minds. This, first of all, is just a statewide look at the average temperature during the whole month for every site. Nothing really jumps out at you there. We were around 30 in Stillwater, which sounds pretty cold, and it was, but a little higher in the southeast, down to 38 or so, and then 20s out in the Panhandle. But that doesn't really tell you the whole story. Those numbers deviated from normal by 8 to 11 degrees across the state. So for an entire month, the average temperature was that much lower than normal. And that's a huge amount for averaging over a whole month. So we were cold, but it didn't all come throughout the month. If this is the blue dots there, if you can see them, are the normal temperature. So as you march through February, February 1st to February 28th, you see, as you'd expect, the average long-term temperature gradually increases. That's, we're working our way into spring. So it starts out around 38 or 9 and gets up to 45. That's kind of the historic norm. And then the orange that you see is what happened this year. So we were actually a little warmer than normal in the beginning and end of February. In between's a different story. Dramatically below the long-term averages. And you see those February 15th and 16th dates, how it was especially that way. But for an extended period of time, we were just way below normal. So February 15th, as it turns out, was the single coldest day statewide since at least 1915. So you take any day of the winter, that's the coldest day ever, no matter which month, which day, whatever you're talking about. And the reason it says at least 1915, our climatologist said back then, before that, there really weren't enough sites operating in a state to really have a good judge of what the statewide temperature was. So we could almost say, probably since statehood, but we can't really prove that. And then also for 2 and 3 day periods, the 15th and 16th and the 14th to the 16th set records statewide as the coldest periods ever for those time periods. And if you're curious, the 4 day through 7 day coldest periods still belong to December of '83. And I actually remember that month because that was the first month we were in our house here. And wow, the utility bill was unbelievable. That December of '83 was another very, very cold month. Early in the morning of February 16th, this is like 1:55 a.m. So when I say early, I mean early morning. Every site in the state was measuring below 0, which for Oklahoma, I mean, we're far enough south. That's a pretty highly unusual event. And many all-time temperature records were set during the month. The blue values that you see there were new site records that were set in February of 2021. So what, like 3/4 or 2/3 of all of our sites. And this goes back through all the records. This just isn't the 27 years of Mesonet. You see the -31 up there in the northeast for Nowata that we talked about earlier. That they didn't eclipse that this time. And Stillwater apparently had a -19 at some time in the past. We didn't quite get to that this time. So the black ones were records set previously. But anyway, just further evidence of how unusual this was. This is what we call the monthly summary for Stillwater. By the way, these are all available on the website. You can go back to any year, any month, any site, and pick out a day-by-day table like this. It shows you what the weather was like. So if you want to check out what your wedding date was or whatever special day, you can go back and do that. And I've highlighted that period of the 13th to the 19th here. You see our high and low temperatures as measured by the Stillwater Mesonet site, which, by the way, is just west of campus out there on what we used to call the agronomy farm there, behind the white fences there. There's a station there that's called the Stillwater one. So you see the -15 there that we hit on the 16th. And then I highlighted in green there, just a few days later, we were 65, 76, 62. So the old adage, if you don't like the weather, just wait a while and it'll change. So we have all this technology, but we do have a backup plan. And this is our low-tech backup plan. If things break down, we rely on the weather rock. And that's pretty accurate, but probably doesn't measure quite as precisely as what the Mesonet does. So I've hurried through a bunch of stuff. I probably spent more time on the data than I did on the network itself, but I'd be happy to take any questions that you might have about it. Yeah.
You said you had two-way communication. What do you send to the sites?
Okay, the question was with the two-way communication, what do we send out to the sites? We obviously get the data sent in. We can send out updates to data logger programs if we tweak our data logger is basically a little computer that sits there with all the sensors plugged into it and has a program that on a regular basis measures all of those sensors. So we could update that. We could reset a clock if it got off a little bit, or we could query it to see if it was working the way it's supposed to and things like that. So it's kind of like remote access into a computer in a way, except we're doing it over radio waves. I didn't mention the form. Most of our data is done via radio. In some cases, we've gone to cellular, and in a few cases, we're close to a Wi-Fi router that we can do that, but the great majority are still radio. Yes.
So is there video monitoring of the stations? I mean, if you get something weird, can you that my brother's not up there trying to...
The question was, is there video monitoring at the site? And that's a good question. We have played with that. We have put cameras out there, either pointed them down kind of with a fisheye at the surface or out on the horizon, tried different things, but we have not yet installed or done anything like that on a statewide basis. Been more experimental. It takes quite a bit of bandwidth, to move that kind of video information across. But I wouldn't rule it out in the future. It takes quite a bit of power, things like that, but it's a good question. Yeah, Jim. The question was, has anybody reviewed this with respect to global warming? That's a good question too, because initially we're just a weather network, and we still are a weather network, obviously, but the climatologists tell us that once you get 25 or 30 years of data, maybe 20 years, you begin to have a climate, what they call a climate record. So weather is what's happening recent past and right now and tomorrow, whereas climate is more of the long-term type of thing. And so our data set, I think, is going to become more and more valuable for looking at global warming, where we have the same site and the same type of instrumentation there for years and years and years. I think we'll have a pretty good, and we also have a very strong emphasis on data quality, quality assurance. We, when we get a new sensor from the manufacturer, we don't take their word for it on the calibration. We put it in our lab before it even goes out to the field, and then they're rotated on a regular basis. So, and we check the data both by computer and by human. So there's a lot of attention given to data quality assurance. I think that'll prove beneficial later on. I'll get you.
I have a couple questions from Zoom. The first one is, can you talk about the ticker on the app? That guy is hilarious.
Oh yeah, the ticker is like most days of the week. I don't know if it's always 5 days a week, but several times a week. Gary McManus, who is our state climatologist and a little bit of a clown, he writes an informative piece. It pulls in something about what's happened, but also a lot of times the future forecast. And Gary, for one thing, he's a movie buff. He sees more movies in a week than I see in a year easily. And so he weaves that kind of stuff in there, which I usually don't understand because it's a movie reference. But yeah, he is kind of funny, and he has his followers. So again, that's something you can get either at your desktop or laptop or on your phone, is the ticker. If you just Google Mesonet ticker, I think you'll find it. And I should mention, I talked about forecast. I want to make it clear, the Mesonet does not do forecasting. That's not our gig. We measure what's happening, but we don't forecast. But we have a very close partnership with the National Weather Service, who are, of course, the paid professionals, our government folks that do excellent forecasting. And they allow us to send out their forecasts through our communication network. So that information gets out and it's on our website, but we're not the ones producing the forecast. So you had another one?
The other question is, how many stations each year are damaged by severe weather?
Another good question. We'll have wind damage from time to time, or hail that'll, if some of our sensors take a direct hit from large hail, it's not real good. We had 2 stations in our history pretty much wiped out by tornadoes. One was in Tipton and southwest Oklahoma, and then Fort Cobb, which is a little closer to Oklahoma City, still in the southwest. And they got, whether it was debris, I think a lot of it was windblown debris that just trashed it, or just the wind itself. But lightning was our big worry at first. When we first installed this, we were really worried about lightning. And we've had some hits and some things fried, but we've gone to lightning rods and grounding at all of our sites. And we still have some lightning problem, but not near what we had before. We've been pretty pleasantly surprised about that. Steve, you had one?
Well, I remember some years ago, there was a discussion about using tethered drones to get data from higher in the atmosphere. Did anything ever come of that?
Yeah, another good question was, is there anything going on with drones in the atmosphere to measure what's going on up higher? We only go 33 feet. And yeah, there's quite a bit of active research in that area, both OU and OSU. It's another example of a pretty good partnership. Of course, you've probably heard about OSU's, I forget what the center is called. You probably remember, but there's a lot of activity on UAVs or drones here in Stillwater. And likewise, there's a lot in Norman, and much of their work is tied to atmospheric measurement. And they've partnered up on some things. They've partnered with Mesonet, and they have, through various experiments, they have sent drones up at the Mesonet sites to get the vertical profile, which I'm not a meteorologist, but meteorologists rely a lot on what's happening as you go on up into the atmosphere, the profile of temperature, wind, humidity, and there appears to be great potential to use UAVs or drones in that way, and there's active research going on. They've coined the term 3D Mesonet, so that would be the third dimension going vertical. Yes. Do other states have something similar to this? Yeah, there are other automated networks in the country, but I think we're the clear leader without bragging too much. When we first began to discuss this in the middle 80s, we looked at some other states. Nebraska and California had networks going, and we learned things from them. And we continue to share with others. If they, there'll be scientists come in and spend a week at our headquarters just trying to learn more about Mesonet. But nationally, I don't think we have any peers. There's a national Mesonet movement where they're trying to bring data in from all these state networks into a federal repository, and we're kind of looked at as a flagship for that. We've also had a lot of interest from other countries with the Mesonet. So we try to stay on the cutting edge and be out front on things. Yeah. Yeah. Yeah, you guys are asking good questions. The question was about measuring ice or frozen precip, what happens. That's one, I guess you would say, weakness or shortcoming of being out in the country and battery operated and solar powered. We don't have gauges that melt snow or ice or hail or sleet, artificially melt it. We have to wait for Mother Nature to melt it. So our winter time, we don't have snow totals. And if we get sleet or snow in our rain gauge, it has to sit there and it melts sometimes hours, sometimes days later. So that's just something we've lived with for all this time. Of course, in our climate, that's not a huge deal, but it's still a kind of a hole in what we do. And a lot of it, again, is traced to the energy requirements that would be needed to heat all that and melt it. But good question. Anything else? Yes.
Whose brainchild was this? Who's the founder of Mesonet?
The early history was that several of us here at OSU, for our own research, our own personal needs, really would like to have had more timely data. We would have to, like I worked in irrigation scheduling, water management. We had to wait for 30 days for the federal reports to come back, the monthly reports for what was measured on a day-by-day basis in sites in Oklahoma. And that was just my example, but there was a couple of other faculty here that had similar wishes. And then at about that same time in Norman, some folks at the National Weather Service and at OU, there was a bad flood in Tulsa in, I think, 86 or something like that, and caused loss of life. And there wasn't adequate warning like there is now. They just didn't see it coming, and they didn't know the rivers were up. And so it was a really serious event. And the people there in the weather community in Norman said, can't we do better? And just kind of by accident, we found out about each other. And of course, we were coming largely from an ag and natural resource viewpoint here, and they were coming from a meteorology viewpoint. And we thought we could marry that up and cooperate rather than compete. So there were some early discussions in about 87, 88. A lot of ideas were put down on paper. We thought we had something that was a real go, but we lacked money. And then in the early 90s, Governor Bellman released $2 million in what was called oil overcharge funding. There was a national settlement about price gouging by the oil companies. So the money got sent out to the states. And if you could prove an energy related connection to that, you could justify spending money on that. And we went to Governor Bellman, the two universities. I think he was so shocked that OU and OSU were asking for the same thing, that he approved that. So that was the big kickstart. The two universities put in a total of 700,000. So it's 2.7 million to get it designed, built, on the ground, running. And then we scrambled those first few years to keep it going with maintenance funds from the legislature and from cabinet agencies, and the Noble Foundation helped us a bunch with a big grant. But after we got through those first few years, our funding became more stable through the state, and we made a go of it. But that's kind of the quick history of it. So we kind of call Governor Bellman the father of the Mesonet, because he turned that last stone over that we needed. So that's probably more than enough, right, time-wise? So thank you all.
Mr. Elliott, thank you for your presentation today. Stillwater Frontier Rotary supports literacy, and so we'll be donating a book in your honor to the Stillwater Public Library. Thank you to all our guests who joined us today, all those joining us in person and all those joining us via Zoom. Join us next week, please. We're going to have, who do we have? Janet Foltz from the Payne County Youth Service is going to be here March 25th. So join us for that. And if there's nothing further for the group, then we'll adjourn with the four-way test.